Hello and welcome back to this mini-series about Java Reflection API, where we try to rebuild common use tools that are reflection-based. Last time we covered what is dependency injection and how we can implement it via constructor. But for today, we're finally going to build Spring-like dependency injection framework using reflection. So let's go over quickly a dependency injection and understand... You know what? Let's do two things at the same time. I will make myself tea and cover the basics of dependency injection. Okay, now that we have a change of scenery, let's quickly recap what was a dependency injection. So, to make a tea, we need three things. A cup, water, and a tea. So let's consider cup as our component. So when we don't use the dependency injection principle, all dependencies are hard-coded inside our classes. So if we imagine that cup is our component and we have a dependency to a tea and a hot water, it means that there is already something inside. So it means that I have just hard-coded the tea inside the cup. Same goes as with component. So if someone wants to use my component or my cup, he will need to use what's inside there. So without dependency injection, I have already selected what tea will come with this cup. So if our guest doesn't like this tea, there is no option for him to change it. Same way as dependency injection, we don't want to hardcode any tea inside, we want to inject it from outside. So our guest comes, selects one of the teas that we provide, or he brings his own, and just injects it. And that's for the dependency inversion principle. So ideally, dependency injection framework should follow also dependency inversion principle, which means that high-level module should not rely on low-level implementation. I don't want to be directly dependent on this lower-level module by pouring it directly in my cup. That means if something changes tomorrow, tea is not provided in such form, my process could fail. So ideally, we want to define an interface that is commonly used by our cup and by the tea maker. So instead of every time seeing different implementations, we want to say that we are only accepting a tea bag. In this case, tea bag becomes our interface and our cup depends on tea bag and tea provider also depends on this tea bag. I don't care how the tea changes or how it looks inside. As long as it is implementing our interface, I can inject it inside my cup. And if I don't like this tea, I can throw it away, take different implementation and inject it. Or use adapter pattern to implement our tea bag interface. I mean, it counts. And now let's get some hot water and go back to coding. And now let's continue. How does usually these dependency injection frameworks work? So usually they start with a container, which stores all of our instances that needs to be managed by the framework. So we are not interested that framework handles all of the classes that we have in our class path. We only want framework to focus on those which are marked with some special annotation. For example, component or service. When we have a list of marked classes with this special annotation, dependency injection framework on startup should scan all the class path and find all the classes that are with this annotation. When the framework has all of the lists of components that he needs to manage, he will gather them and create instances for them and store in our IOC container. So this container is like a global scope we can create as a static class where we put all of the instances and retrieve from any place of our code. Because of that, we need to make sure that it's working as a singleton and it's thread safe. Of course, frameworks like Spring support also different kind of scopes, like request scope, that some instances live only on this one particular request, but we will not focus on that. Application context will be a static class, which will be just a container where we store globally all of our singleton instances of our components. Okay, there are two things that I want to handle. One is storing the instances and retrieving instances by class. So let's start with the retrieval. We will want to have some function that will return this any instance, get instance by provided class. We will have a static map which will have a key, a class, and an object as a value called instances, and let's it be hash map. And to retrieve it means we just need to extract an instance from this map. But of course we would like to also have some safeguards, so let's check. So if the instances does not contain this class, so let's throw a runtime exception and say that such instance does not exist of class does not exist. And let's put this class name. Okay, now that we know that there is an instance, we can just return instances, get, and provide this class. And again, to make it more user-friendly, let's introduce generics. So instead of returning some sort of object, let's have a t parameter, return t type, and have a class of t. Which means we need also to cast it to a t instance, which will produce a warning, but we know that if we are trying to find it by this class, then it means that it is an instance of this class. And now for registering components, let's create a register function, which will take some sort of instance. And what we want to do is to insert and store this object. So we would like to find out what is your class and store the instance. But I would like to also have one more registering function, which will not only accept an object instance, but also a class which it should be registered under. Why we need such class? Because when we are registering component, we are taking the class that is of this object. But we know that Java is object-oriented programming. It can be extending something, it can be implementing interfaces, and all of them are matching candidates to be injected. Maybe we want to inject by a interface or by some abstract class. So that's why let's create some sort of T class here that we will provide T instance. Let's make this function generic and register an instance under this class. So now we can look how in principle dependency injection could use our container to store our dependencies. In the application context, we would register a component. We would register the MySQL component under the MySQL connection class. We would register a bcrypt component. So we now have created two instances that are stored in our container. But probably we also want to store them under the interfaces that they implement. So for example, under the user repository class, we want to store this MySQL connection as well. And same goes for the hash functions. So this will be done under the hood. When framework will start, he will scan for the classes and register all of the instances by itself. And then for us, it will be as simple as instead of using here connections, we would like to ask application context to get the instance of user repository class. And same goes for the bcrypt. Instead of getting hard-coded instance, we would say that we want some hash function class. And now our out service does not care, because we can replace at any moment the bcrypt with something else, and it will be automatically injected here as long as it is a hash function. So no longer we have any specifics, we operate with abstractions. So we say, okay, framework, I need this dependency of type hash function, please give me. And by this, at any time, if for example bcrypt has a vulnerability, we can just replace it with any different implementation and the framework will automatically inject it into our out service. Right now we have done that by hand. Time to move to the framework part. But we need two more things. One is a component annotation, which we can use to mark our classes to be handled by dependency injection framework. And an inject annotation, which is used to mark our dependency fields to be automatically injected by the framework. And now let's mark our MySQL connection as a component and mark our bcrypt adapter as a component as well. So these are two components that needs to be created by our framework. So now that we have those as a component, we would like to go to the out service and mark these fields that they need to be injected from outside. Just like that. So what it means is actually that we no longer need this constructor. Don't get me wrong, this is a good practice, like Spring always recommends that we should stay for it because it's much easier to test and mock such classes without frameworks. But we would like to get rid of it and have a simple injection by the fields. So ideally we can now remove this part and we need to remove these final keywords. So now instead of us passing these instances, we would like to them be handled by the engine itself. So before we do any scanning and instance creation, let's start simple. We will register manually some components in our application context and we want our engine to inject them automatically in out service. So for that I will create an instance for our dependency injection engine. And I want to have one function that is called inject. Engine automatically inject all the dependencies inside this out service. So let's create such method, but instead of out service, there will be a generic object. And now we want to do something simple that we have already done. We need to get the fields, scan them, and set the dependencies. So let's create a helper function that will return a list of fields, which will be called find dependencies, and we will provide some sort of class for which we are using that. So first of all, we need to get the list of fields that are present in this class, and let's create a stream of them. Then we want to filter out all of the fields that has annotation present on them, which is called inject. We want to collect them to list and return them back. Okay, now let's gather all the dependency fields, by calling this method on class of this provided object. We can iterate over all of these fields and retrieve dependency type to look for. So field get type. Now we want to get the dependency instance from our application context. So get instance of this dependency type. There is a typo, the dependency type. Now that we have the instance, we can inject it by setting a field, right? We have already done that in past. First of all, we need to make this field accessible, and then we want to use this field handle to set for our instance, provided instance object, this field, and we want to inject our dependency inside. We can just try catch it outside and retro adjust it as a runtime exception. Because if something happened with reflection, probably we cannot continue. And actually for now, that's all. Let's go back and see our code in action. So we have created our dependencies outside currently manually. Then we have manually registered them also currently. Then we created our out service, which requires two dependencies to be injected, but we do not provide any implementation here or in the constructor. But we want our engine to inject them in our out service. So let's run it, and we can see that it's successfully executed. So now that we have implemented injection, we would like to implement also a component scanner and automatic component registration. So we would not have to perform any of these actions, that it should be handled by the framework. For that, let's create a separate class that will handle this functionality. So goal of this component scanner is to scan whole class path and try to find those classes that are marked by add component annotation. For that, let's define a function that will return a set of unique classes called find components. So if you're working with Java for some quiet time, you know that there is a class loader that has this information about loaded classes. And let's try to get this class loader and see what it has. So class loader, there are multiple ways how we can access a class loader. One of them is class loader get system class loader. We are searching for Java classes, so usually they are defined in some sort of packages. Let's get a list of packages that are loaded by this class loader. And now let's quickly go over them and see what information we have. For each package, let's see what the package holds. For example, get name and return set of just not to have any error. Okay, let's quickly add component scanner just to do quick test. And let's run it. Okay, in the result, we can see that it has detected 3 packages. One is com IntelliJ execution application. This is probably some tooling that is being loaded together with our application when we are running it through IntelliJ. And 2 packages that I have. Now that we have packages, we would like to scan them for classes. Let's define a helper function that will return a stream of classes. Find classes, and we will provide a package name. So again, we will need a class loader for it. Now we could retrieve a package, but we are not interested in package. We are interested in the contents. We want to find all the resources that are inside that package. For that, we need to ask the class loader for get resources, for example, as a stream. As this is a stream, we will need to close it, so we can use try with resources and catch the exception that we can get, and just let's retro it. So this is now a stream that we can read. It contains some bytes that we can operate with. This resource can be null, so let's handle that and return back just empty stream. Otherwise, it's just a stream of bytes that we can read with any reader, for example, buffered reader, and provide these resources. So now we can read all the lines and stream them, and let's just go over one by one and see what it contains. And for us not to break, also let's return for now empty stream. And call find classes on given package. So let's run this quickly and see that we have listed all of the packages, but no classes are found. And actually that's on our side. Here, instead of package name, which is Java notation that has these dots, we need to transform it to the file path. So instead of dots, change it to the slashes. And result in a list of classes. For example, our out package contains out service, host function, MySQL connection, user details, and user repository. It also could have packages inside. We would like to filter these lines and only handle classes. So resource, and let's filter out if it contains class. Now that we have a list of class names, we can map them and create an instance of this class. For that, let's create a helper function, get class, and provide a class name. So let's create this method, which will return some sort of class. get class using this class name, and we can use class for name reflection function to find this class. It can throw an exception. Again, let's just wrap it and return a runtime exception, because if we cannot find this class, it's better to break, and return it as a result. So, okay, now we're printing classes. Let's run this. And now we have failed with error because we have provided actually only the class name or the file name, the application context.class. But here we need to provide the full path to our class and without this class extension. So let's add the package, add the dot, and here remove last 6 characters. Okay, now let's rerun this again. And we have successfully listed all of our classes. So there is an out service, there is my SQL connection, there is an interface has function, user details class, user repository, etc, etc. Let's remove this for each and just return the result back and remove our empty stream. Now we need to collect all the results from all of the packages together in one single set and return it back. So now instead of this 4th cycle, I will create a stream of packages. Now for each package, I want to call the find classes and provide the package name. It returns a stream, so I will have a stream of streams. I would like to them combine into single one, so I will put a flat map here. So now I only receive a stream of classes. And now I would like to filter out and leave only those classes that have our component annotation. So let's filter and see that this class has annotation called component. And if it is, then we want to collect everything into a set and return back. So again, we gather all the packages, go over them, each of them, collect all the classes, flat map the result into the single stream, filter each of these classes and collect them into a set. Okay, so now in the main, I can here put a print line around this find components and verify that we only have gathered components. And in the result, we can see we have a bcrypt adapter, which is our component, and my SQL connection. All other classes got ignored. So now that we can find all the classes that are marked with the components, we need to create instances and inject them inside of our dependencies. And actually, as this is something that we want to do once when we are loading this application, I would prefer to put it as a protected class that we can access it in the tests if we need it. But for our day-to-day usage, we will have a static initializer that we will call init, which will perform all of the actions to load everything on startup. I will add here my component scanner. And actually, I would like to extract this inject and find dependencies into separate class as well. So let's create a dependency injector class. And it will do the same things that we just performed, but as a separate entity. So let's copy the inject function and the find dependencies. Then let's add this dependency injector here. Proper way, of course, would be to provide them in a constructor, so it's easier for us to test, but for now, let's have it as it is. So then when we open the main, the flow should look like this. I don't want to create an instance of my SQL connection manually or the bcrypt. I want to get rid of it. Same goes for the engine. I will not create an instance of engine. I want just to, at the startup, say that you need to scan the context and create the components. We no longer need the component scanner because it will be inside the init method. And the registration of instances also should happen inside the init function. So before that, we created an instance and used the injector to inject everything inside our out service. But now we actually want the out service to be handled as a component as well. So it does it automatically. But it means that we should not create our own instances. We should ask application context to get instance of out service class. But in order to our engine detect the out service, we need to mark it as a component. Now flow is simple. We initialize all the components, inject all the dependencies, and get needed service to perform a login and registration. Okay, let's go and implement now the logic. Here in int, we need to find all of the components that are in the class path. And for each of these classes, we need to create an instance of these components. So component get constructor new instance. It can throw an exception, so let's be very generic, and if something goes wrong at this step, let's just throw a runtime exception and fail fast. But if we have the instance, then we need to store it in our application context. So we take application context, register component, we know that it's under the class component and instance. So let's create actually a helper function here that will accept a set of classes, components, and we will move all of this logic here to make things more readable. Now here let's call it, so register components. After we have scanned for components, registered them in our container, we need to inject the dependencies. So here we would need to ask our application context to get the list of components. And for each of them, we would like to call our dependency injector and inject everything inside. So again, we are scanning for components, registering them, creating instances, and injecting all the dependencies. And let's do one little thing to ease our debugging. Let's add a couple of peaks while we're scanning for components. So one will be here when we find a list of packages. Let's output the package name. After going over each package, let's list the classes that are inside. And let's also output the classes that are marked with our components annotation. Okay, so everything is set. We can try to perform a test run. Running this fails with an exception. If we look that we are trying to find an instance class of out service, but out service does not exist. And if you look closely what is the output of our scan, we can see that there are multiple packages. Then in the example package, there are two classes. Then there is one of them component. I agree, the bcrypt adapter is a component. Then there are other things that are just for our engine to run. But if you look closely, so our out service is located actually in out package, which is a child package of our DI example. And for some reason, it has not been detected. If you look back and see what was the original listing of resources that we have in our package, it actually could contain a sub package. Here in our component scanner, we had this filter for only resources that contains the class, or we can use ensuite class. But it could also have a nested, which contains more classes that could potentially be our components. So we need to go recursively down the package tree. So here, let's not just drop the filter, but let's have some sort of mapping for our resource. So if it's a class, then we want to create a substream of one element and already take this get class mapping for our resource. Otherwise, we would like to go and perform additional scan on find classes, provide the original package, and go one child deeper. Then we can flat map this result, and we don't need this mapping no longer. So let's go again over all the lines go over all the resources, flat map them inside. If it's a class, we return stream of just that class. If it is a package, we want to go deeper and perform recursively this scan again. And I think that should be enough. And now by rerunning, we can see we have found much more elements. So we have different classes, then there is out component, yes, success, MySQL component, and bcrypt adapter component. So we have successfully found all of our components. But now we have still an error that it's saying that user repository does not exist. And actually, indeed, it doesn't exist because our out service expects that we will inject a user repository and the hash function. But we are not registering our components under the interface names. We're registering them at their class name. DI engine, we are creating an instance and registering component under its name. We would also need to register for each of its interfaces. For example, component get interfaces. Let's stream them. And for each interface that we have here, we will take application context, register our instance under this interface I. Now let's rerun it. And you can see we have implemented our basic dependency injection framework using Reflection API, which now makes everything much easier. For example, I would like to create a new class controller. I can make it as a component, meaning that it will be detected by our engine. And I can inject a dependency that it requires. For example, out service. And if I will run the code, we can see that controller has been found, and it means the out service also was injected. Congratulations, we are at the end of our basic dependency injection framework. In this little journey that we did together, we went through the basics of Java Reflection API. We saw how we can scan classes, create instances, get the data, inject some values, and that everything dynamically without knowing any implementation details, which allows us to create different dynamic extendable tools. Of course, this is very simple implementation, and Spring covers way much functionality, and you should of course use those tools. Let me know if you would be interested in expanding this functionality with some of the common functionalities from Spring. For example, components being created by methods, component lifecycle, post construct, properties read from files, and much more. Otherwise, I would like to stop here for now because we have a working MVP of our dependency injection framework, and I rather focus on the next topic, that would be using reflection to generate some of the code during compile time. So if you like what you see, please provide some feedback via a like or a comment, and don't forget to subscribe to not miss the next video. Until then, keep coding, and I see you next time.